Yeah, so find the score that corresponds to the 10th percentile. Find the score that corresponds to the 90th percentile. That's
What question?
questions 27 and 28. Those are the ones that were causing you to struggle a little bit. But other than that, I honestly didn't go through and solve every single one, but I just made sure that I understood how to solve it. That's what's important.
Yeah, that was my problem too.
Mm-hmm.
Let's see.
The sample mean or whatever, the number 31 and 32 are actually pretty easy because I remember how to do that because we just did that last week.
Yeah.
So, yeah.
Okay.
All right, bro, show us your ways. Teach us how
trying
to
to remember. I didn't.
solve these.
I was starting to try to answer all the questions above, and I didn't see that there's because they had that list of bullet points. So I was just going through and finding information for that this morning, and then oh wait, there's all these problems down here. So I got halfway through the problem.
Yeah. Yeah.
So
maybe that was distribution of sample means for a particular size as mean blah 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 blah. Oh, there it is. So it's in chapter or lesson 5.
Find the GMAT score that corresponds to the 10th percentile. Well, wouldn't you just put in?
It says the probability. The probability applet allows us to use z-scores to calculate proportions, probabilities, and percentiles.
Yeah, but wouldn't you just put in 0.1 as the area up top? Is that even possible? Yeah. So that's what you'd do, and then you take everything below that.
Okay. That makes sense.
That's what I would think.
That makes sense.
What number did you put in on the top?
0.1 for 10%.
Oh.
Which would be probability of 10%.
Okay, but then translating that back out to a
number.
To a number is the trick.
So what is it trying to get us to solve exactly?
Well, because the z-score is
so it's saying
1.8.
Find the score. It's not the z-score though.
Yeah, but I'm just saying, can you stick it back? Because the z-score is basically just the end result of that equation.
Yeah. And
so we can do algebra with 2 variables here.
I hate you. Don't even joke around. All right, I'm gonna go back to lesson 5 and see if it teaches anything.
Oh yeah, it just says it right here.
You found it?
Yeah. That whole long thing right there.
Oh, that thing.
Oh, see? Yep.
Okay, and that was in the chapter?
So it is algebra.
Yeah, it is algebra.
Boundary at some time.
But not 2 variable algebra.
Just write down that whole thing on your notes.
Yeah, so where was you found that?
I did
lesson 5.
I did a command F, Control F.
Found it.
That is the most beautiful.
Solve for X. So we know that the z-score equals this.
What did you command F?
Percentile. And then all just popped up
So what exactly?
It's in section 3.
So the question is, find the z-score corresponding to. So there we are. Click on the regions of the graph so that the area.
Oh, so it's you know the z-score,
that makes
but you don't know
perfect
what
sense.
that is. That's what
so you
thinking,
plug in the percentile up top, and then you get the z-score, and you can plug it into the equation. That's what they're saying.
Yeah.
So you know everything except for X, which is what we want, which is the representative number that they're wanting us to get. We could do the same thing for the 90th, same thing for the 10th. That makes sense. Yeah, so you can plug that in and get the z-score. plug in the z-score. You already know the standard deviation. And you already know the mean. So that's how you do that. All right. Last thing,
Okay, so with the 5-number whatever,
5-number summary.
5-number summary, I know how you find the mean, but the other questions like I'm trying to figure out. So like the 25th percentile or whatever is everything at 25
Yeah,
and below.
as far as I understand, it's
but-
basically that box.
But is it the area of it?
That's a good question.
What chapter is that in the quartiles?
The quartile.
I think it's 4.
No, it's not. 5-number summary is 3. So the 5-number summary of a data set contains you. Yeah. Okay, so that makes sense. So you get the median, not the mean. You get the median, which is the middle number. Then you get the lowest number of all of them, which is the minimum. And you get the highest number, which is the maximum.
But what is the lowest number?
The lowest number is.
How do you know?
So you can literally plug it in Excel. So you have a bunch of numbers, right? And then you just highlight them and put
sort
min.
it, right? Yeah. Okay, so it's the minimum.
So the minimum and the maximum.
Q1.
And then the numbers,
The median.
for example, as far as I understand, and then there's another number that's obviously in between the median and the max, and another number that's in between the median and the min. And that's
but calculating those numbers that are in between.
It's not that difficult. It's literally the number that's in between the median and the min.
But how do you know where that number is? Like if it's
So
in
you
between.
so what they're trying to say, I think, from what I remember, is you just take the median and the min, you add them together, and you divide by 2, and that'll give you the number that's exactly in between them. And you do the same thing with the other number.
I wish they let us see if we were right. with these
Yeah.
questions.
Yeah, that'd be nice. But I guess that's what the quiz is for.
Yeah, we might as well just start the quiz right now because they're the same questions. She
Yeah,
said.
honestly, I think we could
Just
at least
so
get
as
an
we
80
solve
at
them
this
right
point.
now, we just throw it
And
in
then
the
we
quiz.
could see what we have to work on and then go back and figure that out and then do it again.
Like the group meeting things scheduled.
Schedule. It's not. No.
What do you mean?
Is
Actually,
it like due today? Yeah, let's do it.
Let's do it. You didn't hear that.
I met with my group and completed the group quiz with them.
Okay.
Wait,
You will need this, that, and the other.
that's cool. So like the only time they ask the question like, did you complete the assignment? It's like no, I didn't complete the assignment. But it's not asking that question this time. It's saying I met with my group and completed this group quiz with them. It's like, yeah, I can say that.
Complete the assignment. Yes, I did.
Which of the following variables is /r categorical? Oh wait, this is an open note though.
No, it's okay. It's a categorical. You're
It's
looking
the-
at a category, not a number.
It's just like,
So branded based.
Oh wait, this is. Oh, this is our quiz. Or like that's the same question as.
yeah.
The mean IQ test is randomly selected students took an IQ test, and the mean of their score was 12. Which of the following statements is true? So I remember that the
Yeah, because a parameter is something that's usually not. No, wait, this isn't saying anything about parameters.
So the statistic is what they took from, and then the parameter was 112, as far as I remember.
I think it's
Well,
reverse. I think
yeah,
the
'cause I-
statistics the 112, like the actual number. And then
Mean
Yeah,
IQs
'cause-
in the United States is 100.
The parameter is like usually
But they're both known, so that doesn't.
I don't know. I think the statistic is 112, but
Actually, so we're supposed to mark twice. Well, we can just no.
just mark all 4.
So you think the statistic is a? No, I just mean we'll know what's right next. You think that 112 is a statistic and 100 is the parameter?
wait.
I just remember that it seemed logical, what I thought, and it was wrong.
Yeah, I'm just trying to think through this. So
I'm pretty sure a statistic
Is-
refers to like a wide range, like a general rule. Like this is the statistic of so and so, and then when you take it more narrow, I think that would be the parameter.
What's statistics?
okay, so the difference between these two things is the mean IQ test score in the United States is 100, and then the mean or 20 randomly selected statistic
Yeah.
students.
Uh-huh.
I mean, their scores was 112.
Yeah.
So one is for the entire nation, and then
one
the
is
other is
a lot smaller.
Yeah, is a lot smaller. So is a parameter like bigger? Like, because like normally like a parameter is like we have to work within these parameters.
So the reason that I think that
Is
100 is the statistic, not the parameter, is because whenever you hear people talking about statistics, they're not talking about a small sample. They're usually talking about the statistic of like the entire nation.
yeah, but just like the very word of parameter, like because yeah, it's like something that you have to work within. So it's like you have the parameter and then you have a statistic, which is kind of like a sample of that.
Well, at this point, we have a 50-50 chance, so I'll go with your answer. I don't really care. If it's wrong, we can just change it. City has 4 distinct. The property values are very similar within each number, but they vary considerably. This is almost exactly the same as the review. One neighbor has very low property values, and the other has extreme. What type of sample should we collect? So I think that's stratified. So systematic is when you take every 10th of them. Cluster is when you just take random groups. And then stratified sample is when you take 2 groups
Based off of the
and then you take
characteristic.
all of them from those 2 groups, right?
Yeah, that's what it is.
So stratified? Or what did you guys think?
Yeah.
Okay.
When designed experiments are conducted.
So the experiment is then conducted using all the students in the. Okay, so when researchers typically choose a particular district and randomly select teachers of, say, 4th graders. So isn't that actually, that's also stratified, isn't it? Because you have 2 groups, not a simple random sample. It's not a very voluntary response sample, either systematic or random sample. From what I remember, systematic was taking every 10th or whatever.
Design experiments are conducted in a public school system. Researchers typically choose a particular district and randomly select teachers, say, of 4th grade students in that district. Because you're taking one part of, or like you're taking one group of teachers and you're hoping that they're representative of all the teachers in the school district. So it's like you're taking all 4th graders, and I know that's one of them. Like you're taking one people. Is that a cluster one? Because you're taking people and you're trying to like say like this is what the whole population is like.
I think it might be a cluster.
It might be because I know number, like, for example, number 7 It's a cluster since we're comparing Democrats and Republicans. So those are two clusters
Number 7.
that it takes in.
Number 7. Let's
I think
to adequately gauge opinions on both sides. Researchers took a list of registered Democrats and selected a simple random sample of 100 people. Then they took that's then they so there's the problem is there's this cluster and then there's stratified, and they're very similar. One means that you just take a group and then you take everybody in that group, and the other one is you take a group and then you do a simple random sample within that group. So from what I remember, the stratified is when you take a group and you take all, and then the cluster is when you take individual groups and you take a simple random sample. So I think he's right. Does that help us answer the other question? Are you going ahead of us, Seth?
No, I was just saying because I think that one down there
Come back down to our level.
is a cluster, and so this one.
Okay, so number tended was entered into a drawing at the end every 6th. So when it's every 6th, that's a systematic.
No, it says 6 names were selected. At the end of the name, at the end of the evening, 6 names were selected to read prizes.
Oh yeah, you're right. That's a simple random sample. Sorry, I didn't read that right. Okay, so we're going back now. 4th graders in the district, the experiment is conducted using students. So it's saying that, and randomly selected teachers of say, this is also randomly selected.
Well, it's taking one subset and then it's trying to extrapolate that person to like say this is the rest of the population. So it's not the same thing as a stratified sample. And it's not
a clustered sample, and it's not a systematic sample either.
No, I think it's a clustered sample. It's not a stratified sample because it's not the same process as what we said in the question above as a stratified sample. So that one's already out. And then a systematic random sample, it's not random, because you're taking it from like specific people within the thing. It's
so
not
maybe there's
response.
2 cluster sample answers.
Yeah,
that's okay.
That's what I would think.
Yeah, I can
all
see
right.
that.
Survey was taken of purchases at the crossroads. Open the data file and use this data to answer the next 3 questions. Okay. Gotta open the data file. Standard deviation of the amount spent. So literally, you're just calculating the standard deviation once you open it.
So, okay. So calculating the standard deviation. Oh, okay. So the mean first, right?
I mean,
Using software, calculate the mean of the amount spent.
Yeah. So to calculate
Is that talking
the
about
mean,
that old spreadsheet that does everything for you?
you can literally just do that. Yeah. Like I can just plug in the mean. I don't really care if I use Excel or not. You can just go to the bottom and say, what is the mean of this crap? It'll tell you.
Round to 3 decimal places. Did you get 4.77?
I haven't done it yet, I'll be honest.
Yeah, 4.771.
Using software, calculate the standard deviation of the amount spent.
4.77.
Yeah.
So calculating the
4.771.
standard deviation, don't you have to take it against?
4.77.
You have to take every answer against
the
mean, right?
So to calculate the standard deviation,
let's use the standard deviation tool.
you can just do the formula.
But I mean, I can't anchor it against.
But what they were doing was
Yes, it's using software to calculate the standard deviation. So
yeah, it says your software. So just
Like
calculate it and we'll plug it in.
1.1.
Which one did you use though? Like standard deviation?
I just used the normal one.
S. Or whatever. You got 1.912.
912.
You get something different?
I did with trying to add up all the deviations together,
Oh,
but I don't know if that.
I don't think that's necessary.
But it should line up with it.
I don't know. I guess it depends on how it rounds.
So is P the better one or S? I don't know
I've
the
always
difference.
only done S.
They're pretty close either way, but
I didn't even use that one. I just used standard deviation without P or S.
Oh.
standard dev.
Yeah.
So that gets you closer to the P one. So it's 1.911.
Then
Yeah,
mark
yeah,
the following
yeah.
statements. I created a histogram
1.91.
representing the amounts back in crossroads. So a histogram. They just want us to create a histogram now. I can do that. I can
I
literally.
created a histogram. So
That's
in
all it's asking.
Excel.
So you can just highlight it, I guess,
Just
and just do a
It's just
histogram.
Oh, because that's all. It's just like inserting a normal chart, isn't it?
oh yeah.
Yeah, it's a histogram
Do you
is
have
a
to
scatter
order
plot,
it? Do you have
isn't
to
it?
order it though?
Yeah, you do, don't you?
Sort and filter.
I think there is an option to just do a histogram though.
There definitely is. Yeah. Let's see.
Insert.
I can even do a box and whisker one.
So they want histogram. That is not what I want.
There's Instagram.
Found
You
it?
found it? Where
yeah,
is
if you
it?
go into recommended charts.
Oh, yep.
Oh, I went there too, and it didn't.
Hey, that's not normally distributed.
I didn't find a histogram. Oh, histogram. There she is. That is definitely not normally distributed.
It's like left, or that'd be right skewed.
Right skewed, yeah.
'Cause you have outliers over here.
So you did that.
Well, I guess we create.
I guess we say
Check that,
true.
yeah.
All right. Jessica and her
point for
research
us.
team measured the body temperatures of a sample of diving elephants. All right, guys. This might be really inconvenient, but I've really got to pee. I'm gonna go pee real quick. Just take a 5 minute. It's all right.
She just hears it in video. It's like,
5 minute break. Well, we should probably just keep thinking through the logic of this.
I'm done.
Okay, Jessica Muir and his research team. So this is the seals problem. They have the representative temperatures. What is the value of the number that goes in the position marked A in the table above? So isn't that where you're just taking, so you find
The
the mean and then you subtract one from the other, right?
I think it's the real number or the number minus the mean.
Yeah, so like Bodil's representative temperature minus the mean.
Yes. Does it give us the mean?
No, we have to find the mean, but all you have to do is take the average of
Oh,
those numbers.
that
So,
was a stupid question.
they made it easy to copy and paste the data out of these things. So,
Yeah.
because like a photograph doesn't help.
So I got that for the mean.
38.
38, yeah, 0.075.
What was it again?
38.075.
Yeah, that's what I got. You get negative.
0.165.
Yeah.
Yeah. It is negative, right? Like we listed as negative. I've always wondered that.
I guess we'll find out.
Man, that would stink you missed a couple of these, and we had to go through 31 problems again.
Well, that is the deviation, or do you just assume that the deviation is negative? Well, that's not always true. There's a positive
I guess
deviation
that's true,
as
yeah,
well.
because it could be negative. Since so we just leave it negative.
Yeah, because I mean, if that really is the formula x minus x, then you have to take whatever the answer
So
is.
doing the homework quizzes, and I kept getting negative numbers, and I'm like, I realized that it could be negative, but
What is the value of the number that goes into the position marked with a b in the table above? So you just take that and square it.
Squared.
Sorry about that, guys.
You're good.
No worries.
Okay, where are we at?
We're finished. Just kidding.
We already submitted it.
All right. That's replacing. Oh, this is the exact same. This is all the exact same thing as the review.
Yeah, it's nice, isn't it?
Yeah, it is nice. So, standard deviation from the mean would be the.
You get 0.027.
No, because you have to do it with
X
b's values
Oh,
instead.
never mind. I just squared it. Never mind. Sorry about
minus the.
So it's 0.6806. 0.68.
Is this number 11?
We're on 12, but yeah, you basically for number 11, all it is.
All you do is you find the mean, right? And then you do the number minus the mean.
Yeah,
Yeah, and what was the answer?
negative 0.165.
Negative 0.165. And then you just square it to get the other answer, right?
No, because you have to take, because in the position B, so you have to take Roberta's temperature.
Oh, yeah,
and
yeah,
then
yeah.
find the
So you do
deviation
the
and-
same thing, but then you square it.
Yeah.
And what's the answer?
I think it's 0.681, but it's still not agreed upon by the council.
What did you get?
I haven't done it yet because I did it for.
Oh, you
someone
did the
else's.
wrong one?
Yeah.
I bet it is. I don't see. I feel like it's a pretty easy problem to not.
Oh, is this just the variance? Is that what it is? It's not the standard deviation. It's calculating the variance.
So one is the variance.
Anyway.
I think the A is variance, and then squared is standard deviation.
Is it?
Yeah.
It's squared deviation. No, because the standard deviation still requires one more computation, or one or two more computations.
So
I feel like.
then what quantity is equal to the sum of the numbers in squared
What was the
deviation?
mean again?
Oh,
The
yeah, I think
mean
you're
is
right. It is the
38.
variance.
0.075.
And then the other column just has no meaning. There isn't actually a definition of that. So what is the standard deviation of these temperatures? So
Should we wait for him to? Well, yeah, I guess.
so what they're saying is they want us to add up all the deviations.
Yeah, that was the same number that I got. 0.68.
So, oh, okay, good deal. So the standard deviation, though, it's the number minus the mean divided by what?
Oh, it's divided by the
Sample size? No, that's
no. Where was that?
It's divided by the mean divided by the sample size, the square root of the sample size.
Is that what it was?
Is it always the square root?
Well, I could tell you what the standard deviation is in a second. I could.
I think so.
7.25.
Oh, well, I guess you could use the Excel formula to figure out what the standard deviation is of it.
Super easy. Well, so let's do this. Let's do it the way that we think it is, the longhand, and then we'll compare it to what Excel gives us to see if we know how to do it the longhand the right way. So ST
Well, because
dev.
so 0.715.
0.715, yeah.
What is the standard deviation of these temperatures? Okay, so then the way that you do it is you'd add all those things up and then you take the square root of what you all added up. If I'm remembering this chapter right, square root.
Oh, that's right, yeah. You square root it at the end?
And
yeah,
then, and then there's
yes.
something else.
No, I think that was it.
but it's not 1.2385879.
Wait. So where are you
I
doing?
added up all the deviations and I took the square root. Oh, this is the square of the deviations? Yeah.
Yeah.
So this is the squared. You add that all up. Then there's this, but there's one more. I swear there's one more thing that you do.
That you divide it by.
But I don't know what it is.
I never
Divided
found
by the
out.
mean? Just kidding, I don't know.
I never found out if we can use our notes on these quizzes or not.
Well, I don't think so because it doesn't say we can.
I don't remember.
But I mean, we could use that standard deviation and then we could go look up the formula if we're wrong.
After? Sure, let's just plug it in. All right. 0.7. 3 decimal places. Yeah, that's right. All right. So, next question is, under certain conditions, the standard deviation can be negative. I don't remember that.
I think it's true. I mean,
Can the standard deviation be negative, though, if you're squaring the variance?
it's when the square number goes positive.
Oh, well, the variance can be negative, which is what we calculated before. For the standard deviation, if you have to
It'd always
square
be
and then take the
positive.
square root of it, yeah, probably.
I think it's always positive.
What'd you guys get?
But do you always square the standard deviation?
Huh?
Because I'm thinking, just in my head, it's like that formula where you have the number minus.
So get the variance. And then you
Oh, well, I guess,
square
yeah,
root
that
it
is the
after.
way that you get it. Yeah, you're right.
What'd
Sorry.
you guys get for 13?
13?
Yeah.
The variance.
Is that what it is?
Yeah,
Okay.
because you have to do another thing to get the standard deviation.
Yeah, because there's a few more steps before the standard deviation.
All right, so
Not that we know
in the
what
same
those
study,
are,
the
but-
researchers placed thermostats, blah, 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 blah. Results are summarized in the table below. So which location resulted in the most consistent temperatures? So obviously it's the one that has the smallest standard deviation, which would be extruder.
Extruderal.
Extruderal.
It's amazing how many words there are in this world.
The number of hours students spent studying for an exam were recorded. The data are represented by the box plot used, box to answer, blah, blah, blah.
So
All
the
right.
third quartile,
Third quartile, I
you
believe.
go by the lines because like the one's the minimum. The
And
first quartile's
yeah,
at
so-
4. Third
So,
quartile's at 6. No, third quartile would be 8 then.
yeah, that's what I was thinking.
Is that right?
I think it goes smallest to largest. So 1, 2, 3. Wait. Actually,
Because one's the min, the first is the first quartile, the second is the median, the third is the third quartile.
there's 4 quartiles, right?
Yeah, but I don't think there's 4 quartiles in the 5 number plot. Because
Well,
like if you
so
think
if you
about it,
look
if you
at-
remember,
This would, if I'm right, this would be a quartile in between these. This would be a quartile. This would be a quartile, and that would be a quartile. Or is there 5 quartiles?
well, there's 5 numbers, and this represents each one of the 5 numbers, but you don't have all 4 quartiles in the 5 number summary. Because the first one is the minimum, then you have the first quartile, then you have the median.
Are those the
Then you have-
quartiles?
Yeah.
Because if
No, those are
that's
the
the case, and it went from 1 to 5, I guess it'd be 1, 2, 3, and then the median would be the third quartile. Because this is a quartile.
Yeah, but if we're going off of the 5 number summary, which we got from the book,
Mm-hmm.
then it goes min, and then first quartile, and then median, and then third quartile.
Oh,
And
that's
then-
what you mean. Okay, yeah. Min,
Is-
first quartile.
Because there's only 5 lines on
Median,
this. 1, 2,
second
3,
quartile.
4, 5. Yeah, there's only 5 lines. And there's,
Oh, and so
So
they're
it's the
calling
max.
these ones in between the min and the median the first, and then
yeah, because
they're
there's only
doing
the
the
first and
third here because that makes sense.
in the 5 number
Yeah,
summary.
yeah,
there's
yeah,
only
that
the
makes
first and
sense. I agree. Sorry for
No,
I had to
That's-
question everything you say.
that's the point of this though. It's like
What percentage lies between 4 and 8? So that 4 and 8 are both 2 away from the mean, basically. So that would be
It's just 50%.
yeah.
This is 25 to 75.
Yeah.
percent.
If the answer is 66, then only put 66, not. So 50?
Yeah.
An observation from a normal distribution.
It's considered unusual, and as to standard observation of mean. There's so contaminants that can harm the city's water supply. Blah 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 blah. Considering how the experience is less than 6 months. It's just a direct nitrate concentration is between 1.59 and 2.52, and values outside this range.
How many deviations it is? Oh, so both of them are 2 standard deviations away from the mean.
Mm-hmm.
So we need to figure out what the standard deviation
So
is.
what they're saying is, yeah, so the standard deviate, the mean minus 2 times, 2 of the standard deviation is 1.59, and then adding 2 is 2.52. So estimate the mean of the measured nitrate. So if we know that the standard deviation, estimate the mean of the measured nitrate concentration in drinking water. So the mean, and we know that if it's 2 standard deviations, oh wait, I got it. So if you do this, so we got to know how much is in between each, right? So if we do 2.52 minus 1.59, then we get the distance in between those 2, right?
Which would be 4 standard no.
Which would be 4 standard deviations. It would be.
So you divide that by 4.
If you divide it by
And then we
2,
can see if the math works. No, you divide it by 4 if it's 4 standard deviations. You're trying to find what one
Yeah,
standard
because you're going
deviation
2 each way.
well, it's asking us what the mean is, not what the standard deviation is.
Yeah, but if you find out the standard deviation, you can figure out what the mean is.
That's true, but if you divide it by 2, you can find the mean. It's the same. If you do 4, you can get standard. Then you can do 2 standard
Well, I'd like to-
deviations
I'd
away
like to
from
check it
whatever.
against it, yeah.
But either way, it's the same. Anyway, so 2.52 minus 1.59 equals 0.93. And if we divide that by 2, it would be 0.465. And if we do it the other way, and we divide it by 2 again, which would be the 4, you get 0.2325, and then you can times that by 2 to get 2 standard deviations from 2.52, and you times it by 2, you get the 0.465, and then what you're going to do is you're going to plug it into the equation.
Okay, so theoretically, 2.25 minus or 4 times 0.93, or if you take the 2.25,
Mm-hmm. You mean 2.52?
2.52, and you minus the 3.7, that should give us 1.59 if the standard deviation is right. It gives us negative 1.2.
Wait. So I need something to write on, whatever, I guess it doesn't matter. So I'm just thinking, right, if you have 1.59 here, just 2 standard deviations away, then you have here is the mean, which is what we know, and then there's another 2 standard deviation, and then there's 2.52. So whatever number's in the middle of both those numbers is the mean. It has to be. It just has to be.
And you say that number is 0.93?
0.9. Yeah. 0.93.
No, well, is that not the standard deviation?
No, it's the mean, because the standard deviation is how much away from the mean
Okay, so,
a number is, right?
so what is the standard deviation then?
So the
So it
standard
should be able to be
deviation would
found
be
out.
2 from whatever it is, right? So if you do
So you do-
2.52 minus 1.59, So that's the distance in between these two. So we're trying to find the middle distance, right? And that's why you divide it by 2 and you get 0.465. So you get 0.465 and then you minus 2.52. So then you get 2.55. 2.055. So if it's 2.055, 2.055, that's 2 standard deviations. So if you do, so 2.055 times 2, you get 4. How is that? No. No, that's right. 2.055. Okay. So you do the number 0.465. And then when you add 2.055, it equals 2.52. And then if you do 0.465 and you minus 2.055, you get 1.59. But you got negative 1.59. How did I get negative?
You can borrow this one if you want.
Just need to step through this.
So I noticed, like, over in the chapter, it was like, to figure that out, you could just do +2 and whatever that is to zero it out on that side and add it over here. So then you'll get that is 1.59 plus that. You see what I'm saying?
Mm-hmm.
You zero it out on one side, switch it over to the other. But I'm trying to figure out if that would get us anywhere further.
So
Okay, so you have the
we know
mean
that
minus
they're
2 standard deviations equals 1.59.
but it's not, that can't be the deal. So what I really want to find out is, that's not.
What does the mean if you measure the
Oh no,
concentration?
0.465 I think might be the standard deviation. I think you're right. Yeah, 0.465 I think is the standard deviation. Yeah, so then if you do,
So we know that both of these are 2 standard deviations away from the
0.465.
mean, which is represented by this.
times 2 equals
7.
0.93. And then you do 0.93 plus minus, so 2.52 minus
So
0.93. 1.5.
this
What
is-
the freaking A?
So if this is the mean right here,
No. This has got to be, wait, I think I know what's going on. So if you did 2.52 minus 4, 0.465.
so the total of this,
How's this so
so the
freaking
total of this is 4 standard deviations.
Yeah.
So in between here and here is 4 standard deviations. So then
So
would you take
which would be the
2.52
0.93 divided by
minus
4?
1.59?
Oh, that's what I'm
that
doing
would give
wrong.
you deviations, and you divide that by 4.
So I got
Tried
this.
that in
The standard deviation, if that is true,
the homework
would be
Okay.
I
Well, we
mean, we could try.
We can plug it back in and check
Yeah.
and see if it's right. So 2.52 minus 1.59 equals. So that's the 0.93.
and then when you divide it by 4, you get 0.2325.
So 0.2.
So that's the standard deviation.
So you're saying 2 point this. So then if we plug it into here, so -2 times by 2 or 0.233, this should equal 0.5.
Yeah. Point
0.465.
times 2. And you're going to add that
So
to
0.465.
1.59. 2.055 is what I got. And then if you do 2.055,
Well, the mean can't equal that though,
why not?
because 2.0 or 2.55.
2.055.
Okay,
So if you do
So is that
2.055,
is that equidistant in between 1.59 and 2.52?
yeah, so you do 2.52,
Because
2.52 minus 2.055, you get 0.465, right?
Mhm.
And then you do 2.055, and then you minus 1.5, sorry, 1.59, and you get 0.465.
so that should be the right mean then.
So the mean should be 2.055.
Yeah.
Okay, and then the standard deviation is what then? Is that
The standard
0.233?
deviation would be 0.233.
Yeah, because that's
And so then you go by over by 0.23.
Yeah. 0.233.
See, look at that. We figured it out.
Between what two measured nitrate concentrations do approximately 68% of the data values fall? So 68% is one standard deviation, right? So you would just take the mean and you would add the 2.233, so 2.055 plus
So you're putting the standard deviation as
0.233.
0.233.
So yeah, that's what we were saying. So yeah, and a good sign is, look, that's actually an option.
Okay.
2.288 is an option for the high number, and there's no other option that says 2.823.
and I got the low number.
2.823.
Yeah.
Bam. There's no
So
way
how
we
did
got
you
that wrong.
how did you find the low and the high on that?
You just plug it in.
That.
Oh, just one standard deviation. Where
Yeah, because one standard deviation is 68.
it's not 66.
What? What are you
Because
talking
it's the
It was
rule is
68.
66.
It's 68. Yeah. It's 68, 95, 99. So
Okay.
Yeah. Mission committee for most masters of business administration, blah, blah, blah. Expedition. Okay, now we're going to get into more but stuff. For the mean of blah, blah, blah. What is the probability that a randomly selected student will score? So where's that normal probability applet that it's not giving us? Not cool. Okay, what is the probability that a randomly selected student will score above 4.2? 5.5. 542.3. Freaking normally they give us the normal probability applet to do this.
Well, can't we use the normal probability applet?
How do we get it?
Type in applet on your Chrome browser, and it remembers where you've already been.
Oh,
That's one way.
there's one way. It just normally they give us a link.
Yeah, but I think we're always allowed to use the applet.
Okay. So
What is the probability that randomly selected student will score above?
so we know that the mean is 542.3, and that the standard deviation is 120.54. Okay, anyway, that point doesn't matter. Okay. So we just plug it in.
We need to figure out what the z-score is.
Just plug it in. Yeah, so we just do the 542.3 minus 542.3 is 0. And then you divide it by
Wait,
the standard deviation, which is 120.454, which is 0. That is the equation. It's the representative number minus the mean divided by the standard
well, I mean,
deviation.
since that's the mean, would it just be 50%?
probably
Like
Be 50%.
because it's the middle.
50% above the mean. Mean's right in the middle. Would it just be 50%?
but it is the mean. It's not above the mean.
Yeah, so that's why it's like right in the middle.
Oh yeah, you're right. I think you're
So
right.
50%
It would be
above
50%.
and 50% below.
I think so. But at the same
But if it-
time, like you could take an average. Say there's one person that got an 8 and 3 got a 2. It's like, what if there's a high number? I don't know.
No, we know that 50% is
Well,
always going to be
the mean-
above
Well, the mean is always going to be in the middle.
Yeah, and then 50% is always going to be below.
It literally is the mean.
So
Yeah.
let's just do it, I guess.
Yeah.
Yeah. So now we have to do
You
the
just put- you
600.
just put 50, I guess.
Or
So
do
we
you, no,
do
you
the
probably
same
put
thing.
0.5 though, because it's in context of like the probability
that
output.
what it
And
said?
when we're talking in probabilities, it's only between 0 and 1.
That's
That's
true.
true,
0.5. Anyway,
As the 3 rules of
so 600 minus the 542.3 divided by the standard deviation would give us the z-score for 23
yeah. So we take 600.
minus 42.3 divided by 120.54 would give us the z-score, and then we plug it into the normal probability.
Divided by the what?
the standard deviation, which is 120.54. You have the normal probability applet open.
Yeah, I do. So I got 0.4786.
Is that the probability or
The z-score.
the z-score? Okay, and so then we plug it into
What'd
the
you
normal
get?
probability applet.
0.479.
Or,
I guess 9.
Yeah.
So do they want us to round though the in-between numbers or just the final?
I mean, it's gonna be a long number if I don't round. No, the z-score is usually only 3 digits,
Yeah,
isn't it?
it's, yeah.
Oh, that's right. Yeah. So plug in the 3-digit z-score, and then it will give us the probability once we highlight.
The probability of what? Is it above or below?
It's
or-
below 600,
So the probability is 0.3160.
and it says that the probability of it.
Wouldn't it be?
Wait, let me see.
It'd be these two combined. It'd be those two. Since the 600's above the mean.
Yeah.
Oh,
So it would
okay,
be
yeah, you're right.
0.684. 684. Yeah.
I really wish you could just take a group exam.
Yeah.
What is the probability? Yeah, we always
It would
seem to
be
do decently
so-
well.
You learn more.
Um,
this is like kind
student
of the
will score-
environment you
okay, so
really
now we're
use in
doing
your life
above.
anyway. Score is 600 or above on the GMAT? Okay.
Oh,
So
so
you
just-
literally just
just
highlight
drop
the
the
other
side.
piece, and it's 0.316.
Yeah.
3.6. All right. Now it's going to ask us to find the distribution of sample. Oh, no, not
So
yet.
the 10th percentile. So that's where you take.
So that's where we put in the thing. We find the z-score.
So you just 0.1.
That's not that bad.
Isn't
So
it?
yeah, it's 0.1. And then the z-score is what?
Negative 1.8.
479.
No.
Z-scores.
No, the z-score is 1 point.
Is
Wait. Why did you point 0.099999?
well, I just put in 0.1, and that's what it did it to. So
Really?
0.1.
Oh, there we go. So it's 1.282. So now we just plug that into our formula, right?
Yeah.
So we take 1.282.
How'd you
and-
get that number?
You
1.282.
just plug
you just
in
plug the 0.1 up
10%
into
in
the
the probability,
into
the
the area,
normal probability applet.
and it gives you a z-score of.
Yeah.
Wow,
I'm thinking that's the way.
that's really
it's
easy,
done.
man.
Yeah,
I hope.
it's plugging it into the algebra. That's
Yeah. So now we just do 1.282. That's the z-score, right? And we do equals, and we're looking for x. We minus the mean, which is the 542.3, and we divide it by the standard deviation, which is 120.54, and we solve for x. Algebra,
algebra. Yeah.
it's on.
Glad that the highest level of math is really just algebra for me, or like business management degrees. So I don't really need more than. I guess this is a form of math too. That's
Mm-hmm.
this is basically.
Your
Yeah, well, like
times and
Okay,
Like one-
so somebody figuring this out.
Yeah, 1.282,
So,
and then you're going to times that by.
because you're plugging it back into that.
Yeah, so you would
equation.
times it by the standard deviation
And the only thing you shouldn't or you don't know right now is
is the representative number.
yeah.
So you times that by 120.54, and then you're going to add the mean to that, and then you would get it. So once you add the mean, the mean is 542.3, and then we will just say, what the freak? What does it say? A. I don't want A. Okay. I got 558.3763. $558, and if it'd just be 558 if we're rounding the nearest whole number.
So you're saying x minus what?
So I did. What do you mean? So x minus the mean.
And the mean is
The mean is the 120.54. Whatever it is.
The standard deviation.
Oh yeah, you're right. No, yeah, sorry. The mean is the 542.3. Standard deviation is 120.54. So the way that I solved it,
and then it equals the
it equals the z-score, which is the 1.282.
Is it the negative one?
Doesn't matter. It's the same either way.
And then the standard deviation was the 120.54.
And it would make sense that the 10th percentile, meaning that only 10% of people score that high, would be the high number, not the low number. It would be a high percentile if it was the opposite. So the way I did it is I did the z-score, and then I times it by the standard deviation, because you have to times it to get rid of the division. And then I added the mean, which was the 542.3. And that's how I got 558.3763.
But doesn't that make a significant difference if it's supposed to be negative and it's not?
So what I was saying is it would make sense that it would be the higher number, because 10th percentile means that 10% of the people scored this score. And a higher score is going to be a less of a percentile than a lower score.
It's like the bottom rung. So it's like 10% or less scored this. So it's going to be.
Or is it the other way around?
No, it's 10% or less. Because a 90th percentile says that 90% of these people scored this or less. Yeah. So that would be the higher score.
So we found it.
So this probably should
So we
be
found
negative.
it backwards. So if you
found
make
it
that
for the-
negative, then it would be 526.2237.
And then
Wait, so we're saying
I changed the 1.282 to a negative number.
I got 387 point.
Well, how did I get a different number? Where are you getting your numbers from?
So yeah, okay. So I took
So this is what I
the
did.
negative.
Negative 1.28, right?
Yeah.
And then I times it by the. Oh, why does that say 12?
I don't know. You just missed the zero probably.
Yeah, it's 387.7677.
which number did you make negative? Were you saying
This one right here.
that one? Okay, that would make a huge difference.
387.
'Cause if you leave it positive, wouldn't that just be the percentile then?
Yeah.
Because
So it would be
what I just did.
So I mean,
388.
we can find the positive. Or the,
So it would be 388.
do we round it to a whole number?
That's what it says.
Then I guess we round it to a whole number.
So you got 388,
Yeah.
388. Yeah.
and then for this next one, it's 697.
697.
I bet I'm
90th
I'm
percentile.
finishing this up real quick.
And what do we got? So 31. Oh, not too far.
Are you serious?
Find the first quartile of the distribution of the GMAT scores. So we just put it at 0.2. 5, right?
Okay. I'll hurry.
Yeah.
I love you. Okay, bye. Oh, poop. I gotta take my wife to class.
Okay, find the first quartile of the distribution of the GMAT scores. So it'd be 0.25, and then so that gives you a z-score of that, and then do we plug it back into algebra again?
Wait, where is it? Which one are you doing?
Find the first quartile, though.
Wait, did
First
you?
quartile.
Are you
just take
Did you
the
already
area
do
of it?
28?
No, it's 27 is what I'm talking about.
Oh.
Because would you just take the first quartile as being like the probability thing, or like the area? Like the area of the first quartile? Is that what we're talking about? Or are we talking,
Yeah.
because we're not talking about a specific GMAT score anymore.
No, well,
So then
I don't know.
But the area of it.
Actually, I don't know because
Well, because maybe to find the area of it, you don't plug in the 0.25. You actually plug in the z-score of the thing, and then you find the area from that.
Sorry, what did you guys get for 26 again?
697.
697. So would you